Okay, watching the Super Bowl here. Antonio Brown just got a touchdown here. So this is going to be your lesson here for the async. Let's click this. Uh, this involves how these quarterbacks are throwing these perfect spirals. A lot of it is the way they move their body, the dynamics, the kinetics of it. Uh, but then there's a specific physics that's kind of related to rotational motion, which we're studying now. That's going to involve spin rate and angular momentum. Now, the kinetics involves the way they move their body, uh, the way their mechanics are, the step with opposition, the way you hold the elbow, your form when you're holding the ball. There's a grip. You know, if you line up your thumb with your middle finger and then let your index finger or your pointer be the last finger that touches the ball, that's going to help it sort of get that snap when you release it. The stance, the release, it's all sort of related to the physics and mechanics of the body. But what they're trying to do is create spin on that ball because the spin is going to make a huge difference in the angular momentum. So on average, a good spiral has a spin rate of roughly 600 rotations per minute. And this creates sort of a gyroscopic motion. The gyroscopic motion of these rotating objects maintains their orientation when they're in rotation. These rotating objects possess angular momentum. And one of the things about momentum and angular momentum specifically is that it has to be conserved. So the spiraling is going to take advantage of this angular momentum. It's going to help the ball stay in the same orientation with the point of the ball facing the direction of the throw while it's traveling through the air. Now, you know, if the ball isn't spiraled, it's going to tumble through the air and it'll be pushed around by the air or even wind in all directions. This really makes the ball harder to catch. The law of conservation of angular momentum assumes there's no external forces acting sort of perpendicular to the object, or they say there's no torque on a rotating object. Okay, assuming that, that let's talk about what angular momentum really is. So, regular momentum, or a straight line, is simply an object's mass times its velocity. This is related to its inertia. But let's say in a rotating object like the disk, like you did in the Ladybug lab, the angular momentum is this moment of inertia, or this, picture a 3D space too, could have this, not just the disk. There's an amount of material in relation to this point of rotation. So it's the moment of inertia times the angular velocity. This is much easier to picture in a version of angular momentum where they call a point version. And then the point version, imagine an object is tethered, like you're throwing a rock on a string. And that is measured simply by the radial distance from the axis. And the radius times the mass of the object times its velocity. So what I would like you guys to do at home today is maybe go on a little web quest for me. Find out what is happening to an object that uh, has its radius shrink. So let's say you start it spinning and then the radius shrinks. What happens to that object? Please find 3 examples from real life and describe them for homework. Have a good day. My face. End meeting.